Welcome to this demo on interfacing Raspberry Pi with NetSim through emulation in the context of IoT. Before we begin, let us first understand what emulation means in NetSim. In simulation, everything is virtual: the devices, the traffic, and the protocols. In emulation, NetSim allows us to connect real applications and real hardware to its virtual network. This means we can run live traffic from physical devices through a simulated network and study its performance. For this setup, we use three systems. The first Raspberry Pi acts as the source and runs iperf. The second Raspberry Pi acts as the destination and runs jperf. The third system runs NetSim and functions as the gateway. In NetSim's emulation application, the real source IP address is mapped to a virtual sensor node. The real destination IP address is mapped to another virtual sensor node. The NetSim emulation server connects them together. We also configure a static route in the source Raspberry Pi so that packets meant for the destination are forwarded through the system where NetSim emulation is running. Let us first look at a baseline test without NetSim. The source Raspberry Pi sends traffic at 500 kilobits per second using iperf. The destination Raspberry Pi receives 500 kilobits per second with no packet loss. Now we start NetSim and run the same test. The source still sends at 500 kilobits per second. However, the destination now receives only around 120 kilobits per second. This reduction is due to the IEEE 802.15.4 Zigbee limits. While the physical layer supports 250 kilobits per second, MAC overhead, backoff, and retransmissions reduce the effective throughput to around 100 to 120 kilobits per second. To summarize, we connected two Raspberry Pis to NetSim in emulation mode. Real iperf traffic from the source passed through NetSim's Zigbee network before reaching the destination. The throughput dropped as expected, confirming Zigbee's performance characteristics. This demonstrates how NetSim emulation can bridge real devices with virtual networks, creating a powerful hybrid IoT testbed for research and learning. Continuing from the previous example, let us now see how real-world sensor data from Raspberry Pi can be integrated into NetSim's IoT simulation. In this setup, we connect three different sensors to the Raspberry Pi: an ultrasonic sensor for distance, a DHT11 sensor for temperature and humidity, and an LDR sensor for light intensity. The sensors are wired to the Raspberry Pi's GPIO pins. The Pi collects the data, processes it, and transmits the readings in real time to NetSim using socket communication. First, we run the server.c on the Raspberry Pi. It starts and waits for a client connection. Next, we launch the configured IoT scenario in NetSim. As soon as NetSim begins, the connection to the Raspberry Pi server is established. Now the Raspberry Pi starts reading real sensor data: temperature, humidity, light intensity, and distance. It transmits these values in real time to NetSim. Within NetSim, this live data is injected into the virtual IoT network. Packets carrying the sensor values can be seen flowing through the sensor nodes, the LoWPAN gateway, the router, and finally reaching the server. After the simulation completes, we can analyze the results. Wireshark packet capture shows payloads containing actual sensor readings, confirming that data has been successfully carried across the simulated network. Now let's look at a real-world use case. Consider a smart greenhouse. The DHT11 sensor monitors temperature and humidity. The LDR tracks sunlight, and the ultrasonic sensor measures water tank levels. All of this sensor data is collected by the Raspberry Pi and transmitted into NetSim. This allows us to test how the greenhouse IoT network would perform under different conditions, such as delays, congestion, or packet loss, before deploying it in the field. Thanks for watching.